Welcome to YayMath. YayMath?
YayMath!
Luckily my abs protected. Oh, is that weird? How do I look in that? Oh, I forgot we're gonna do the thing.
Can you breathe?
Can you breathe?
Oh, right.
Yeah, think I could do it?
Yeah.
No.
No.
Wish.
Oh my god.
YayMath.
YayMath. We're not like
Wait.
What are you?
YayMath. YayMath.
Hey, come to the camera. Come to the camera.
YayMath.
More. YayMath.
How bad is it? YayMath.
No, it's YayMath.
YayMath. That's gonna be our new statement, you guys. Only us. You'll be like YayMath, and you'll be like YayMath. How funny. Okay, let's get into it. All right, we're starting a new chapter, and I love it. It's fun for me. Logical stuff. Okay. So first, we're going to talk about the idea of like logical reasoning. I wrote here reasoning. I wish I had reasoning. So here's how it goes. If you want to look at number 9, okay, there's a statement. Okay, any volunteer to read the statement loud so we can all understand? Anyone? Anyone? Yeah, it's okay. Yeah, go, please.
Given A, B, C, and C, B, D, form a linear pair. Conjecture.
Conjecture. Okay.
Conjecture.
Go ahead.
A, B, C equals C, B, D.
Okay, good. A, B, C, and C, B, D. There you go. That's our situation. They say A, B, C, and C, B, D form a linear pair. So that's a given statement. Conjecture is that what you're going to ask, what a conjecture is?
Yeah, what's conjecture?
A conjecture is basically, this is a statement whether you have to prove whether it's true or false. Okay, so I propose that, so given, we can call angle 1 and angle 2. Angle 1 and angle 2 are a linear pair. Okay, the conjecture is that they're the same. True or false? True or false? Are 1 and 2 the same?
Yeah.
False.
Yes, false. Okay, so what do you think?
I think they just add up to 180 degrees. And
Right, right. So, let's talk about logic, all right? I asked you this yesterday. There was no one in here whose parents are attorneys. This is the backbone kind of behind legal defense or litigation, is finding exceptions, okay? So if you're going to prove something false, you have to give what's called a counterexample, right? I'd recommend writing that word down. Counterexample. Meaning, if something is true, it has to be true all the time. If something is false, it can only be false once and that's enough. Does that make sense? If I said a statement and you said it was false and gave me one time it was false, then you're right. But if I said a statement and said it was true, it has to be true all the time. So you said that 1 and 2 are not necessarily equal. Can you give an example, a situation in which 1 is not equal to here? Now you're thinking. Let me start you off. Angle 1 equals 100, angle equals. Angle 1 equals 100 degrees. Angle 2 equals what, do you think? Yeah?
80.
80. So, given information is still true. Conjecture is false. They're not the same. So this conjecture is false. Yes?
I have a question.
Yes.
On number 9, above the equal signs, like little squigglies.
Oh, right.
What is that?
It means congruent. All right? It's more or less equal, but it's basically like the same in terms of images and graphics. All right? It's like picture equal to picture. Oops. All the muscle here, but not in my hand. Okay, next one. Yeah, ask for the class. It helps. It helps everyone. All right, let's try some more. Given. Who can read it? A, B. Anyone? Yeah, please, go for it.
Me?
Yeah.
Okay, given A, B, B, C, and A, C are congruent, conjecture A, B, and C are collinear.
Okay, good. Me too. A, B, B, C, and A, C are what?
Congruent.
Congruent.
And conjecture A, B, and C are collinear.
A, B, and C are collinear. All right, so the conjecture is A, B, B, C, and A, C are congruent. Must they be collinear all the time?
No.
Yes.
No.
No.
They're never.
Maybe.
Maybe,
They can never
right?
be
It
co.
has to be true all the time. So if we were to say that these are collinear, these points, has to be true all the time. Can you
No.
think of a counterexample when they're not? Yep.
I want to know what congruent meant.
Congruent is that's this. The
Oh,
same.
right,
The
sorry.
same.
It means the
Congruent.
same?
Means the same, yeah. It means more or less equal in terms of pictures, you know.
Like
A, B, B, C, like the segments, let's say. All right, the segment AB is congruent to the segment BC, means the same length. All right, so what do you think? Are they collinear if they're the same?
No.
Okay, can you give a counterexample?
When they're all parallel.
Okay, so let's try it.
The same length, but
So we're
parallel.
trying to come up with an example. Here's AB, then we need BC. Where should C go? It's
Up.
B.
Down.
Down, okay, it works. And AC. And if I said all these were the same. So it matches our given info. Here's our given info. AB, BC, and AC are all the same. Did I actually wipe this with my rippling back muscles? It's so funny. I hit the gym, man. And I gotta, I guess, future men spill coffee too, you know, or whatever this is.
were you drinking coffee this morning in that?
Yeah, I do. I sit around and read the paper. And I'm like, Starbucks! And I like to pump this up, you know. Next one.
Bicycle pumps, you go to school.
That's right. That's right. Or it's actually like in the planes, you can blow in them. Blow up. So, AB, BC, and AC are the same. Are they collinear?
No.
Are A, B, and C on the same line?
No.
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 So the conjecture is false. Clear?
So they have to all be on the same line?
If they're all, the conjecture says A, B, and C must be on the same line. You say false because it's not always the case. Here's an example where they're not on the same line, so the conjecture is false. All right? More. Two more like this and then something else and we're done. Okay. Voluntation to read elimination. Yes, please. Go ahead. Yeah.
Given AB plus BC equals AC,
Given AB plus BC equals AC. Love it. Keep going.
conjecture AB equals BC.
False.
Okay. So we're thinking lines, correct?
Yeah.
First of all, before we continue on, is there any issues, any questions people have? Anything that sticks out that you don't understand? I don't want to leave people behind. Feel free, really. Got your back. I got your back, live with me. Okay. So let's do it. Given information, here's the line. So, there we go. A, B, C. Boom, boom. Here's one example. AB plus BC. Does that equal AC?
Yeah.
Yeah.
Yes, so that's okay. Does AB equal BC?
Yeah.
In this case, does it? Yeah. So I'm going to say this conjecture is true. Am I right?
No.
What do
No.
you think?
Wait,
It's
how do you
con-
know to write that line, like?
I made a
Wait, so a conjecture is.
conjecture is like a proposed idea, and you say whether it's true or false.
So they're
But it
congruent.
could be false too, couldn't it?
Okay, now you're getting there. I'm doing this on purpose. All right, I did this on purpose. If something is true, it has to be true 100% of the time. If you were to say this is true, you have to be like, this is true all the time, just kind of like in life. Something is true. But the second you have one time when something's not true, you can't say it's true anymore, can you? There is no half truth.
There's no
We kind of like get into
Why is
the.
it, what's,
Then why would that be true?
it's,
This
not.
one's true. This
yeah,
one's
but
true.
that one is.
Yeah, but then what?
Right. Give me one that's.
So you can't prove it wrong or.
Yes, prove it wrong. That's your challenge. Prove it wrong. I
You
love
just
this.
proved it right.
I did prove it right.
But it has
It's
to
true.
always
Okay,
be
no, let me get to the conclusion. Hold on. Let me tell you. This is great. Just because something is true some of the time doesn't make it truth. Correct?
Yeah.
Right? Like in life. Think about in life. Just because something is true some of the time doesn't make it true. Just because someone tells the truth sometimes doesn't make them like a truthful person. Right? So, this time, the person that did this says, okay, this is true. This conjecture is true. But someone else would come along and be like, no, it's not always true. So I need an example, it's called a counterexample, that counters this to prove it false. Do you have one?
Yeah.
Okay.
If you made line AB shorter than line BC,
Okay.
that would make it false.
Then what do you put for, you always put false for these because you can always prove it wrong? Or-
You can, not always.
Not
Unless
There you
it's
go.
like a formula or something?
Oh, man, good. Exactly right.
So,
Exactly right. Look, what do you think? What do you think?
but what if someone else writes right, correct?
This is not true. The answer to this is false. Right?
If you prove it wrong, it's always false.
Exactly. So that brings me to the next question. Is it easier to prove something true, or is it easier to prove something false?
It's easier to prove something true. No.
No,
It's
no.
easier to prove false.
I would like things to be true in life. You know, we're all seeking truth, I suppose. But why is it easier to prove something false? Let's hear some other people. Okay, yeah, please, in the back. Go ahead.
Because like you can always change the picture and then like you know what I mean? Like because it's a
You're getting
line,
there.
so you can always like move the point B and then it can change the result.
Right, you're getting there. You're getting there. But there's
It's not like a proven thing. It's not.
you're circling. You're getting warm. How about over here? Anyone? No? This side? Okay, this side's hot. Go.
It's because it's very vague. Like the given is always very vague. It doesn't have like specific like coordinates and points that you need to place on the line. So that gives you the opportunity to move the points around, and that makes it false.
You're
because
thinking
there's
about
only-
this. Yeah, you guys, both of your comments are valid. You're thinking about this particular situation. My question is general. It is easier to prove something false. Why? Yes.
Because to prove something true, it always has to be true. To prove something false, it just has to be false once.
Right. Right. Think about that. To prove something true, it has to be true 100% of the time. So you have to think of every possibility for this. Every possibility. But to prove something false, you only need one counterexample. The second you find that one counterexample, then it's false and you move on. Okay? And I think that's cool. I think that's cool. And another part about it, what I like, is that that's why truth is more valuable, right? Because if something's true, it's true all the time. So it has a lot of value. But if something's not true sometimes, then it's immediately false, and it's in the land of falsehood. Get it? That's why I like this chapter. Are you following?
Following.
You following? It's going to get even better. Okay. And what you mentioned as well, the majority of the time, the true statements are definitions, are rules. You know,
Like
that-
formulas.
Yeah, formulas, rules, definitions. Okay, let's do one more. Volunteer to read? Yeah, please.
Given angle 1 is complementary to angle 2 and angle 1 is complementary to angle 3, conjecture angle 2 is congruent to angle 3.
So they're saying angle what is equal to angle to what, conjecture?
Angle 2 is congruent to angle 3.
Angle 2 congruent to angle 3. Lovely. True or false? So now my mind automatically starts thinking of examples. Examples. How many examples can I come up with? 1 complementary to angle 2. Who can give me one example of 1 and 2? How many degrees, perhaps? What does complementary mean?
Adds up to 90 degrees.
Angle 2 is complementary to 3.
Oh, What does it say?
Angle 1 is complementary.
Oh, thank you. Good catch. Okay. Let's move on with that. Okay. Okay.
Complementary means add up to 90 degrees.
Two angles that add up to 90. Right. So let's think of 1 and 2. Give me some. You want to do them equal? So check it out.
45.
They're saying equal, stuff like equal, right? Why don't we get away from 45 and 45 to try to prove it false?
So 50.
Right? Does this stand the test of truth? So 50.
50, 50,
50 and
30,
95.
40.
40, 40.
Pump you up in your brain. Okay. So 1 is also 50 still. And 3 must be what? 40 in this case. Is 2 equal to 3 or congruent to 3?
Yes.
In this case, yes. What if we change the numbers? What would happen then?
It'd still be the same.
It's always true.
It's always true.
So
Won't it be?
it's true.
This one's true. It's true 100% of the time. If you prove something false once, it's no longer true. That's the point of what we're talking about. Okay, okay?
3 true,
Okay,
1
okay.
false.
All right. So that one's true. It gets better, right? It gets more fun. Here we go. Flip the page, okay? And we're going to the bottom of the page. The paper that you have is kind of like not as inspiring as the following. I'm going to use the following statement, okay?
Where's
So-
16?
I took it out. Okay, so here we go. Right? Love dolphins. I see them when I surf many times. They come up right to the board. A little thought I've had about dolphins is cool, just on a side note. The reason why you love dolphins, you don't really know it, I've thought it through, is because to me, they're the only wild, intelligent, non-aggressive animal. Think about it. The only animal in the wild that are intelligent and non-aggressive. Right? Everyone else is either like intelligent and they want to eat you, or they're just dumb, like a bird. You know? You look at the bird, you're like, "Hi, bird," and they're like, you know? They'll just like do that, you know? Pigeon. I could do a great pigeon. Listen.
Oh my god.
But they're dumb. That's the problem. They don't want to eat me, but they're dumb. So that's why all dolphins are cool. Now, can you make this into an if-then statement? We're going to make some rules. Okay? An if-then statement. I'll start it off. If an animal is, and transform. I know, it's out of the clear blue sky. I want to see if I get lucky. If an animal is a dolphin,
It is always
Then
a
it is a
man.
mammal.
then it is a mammal. Right. So let's write that down.
Oh, isn't that called an if-then statement?
Yes. Indeed.
Good genius.
And then genius. Okay. If an animal is a dolphin, then, I'm going to underline the if and then, it is a mammalia. Okay. Good. So, what many times people in the geometry land do is they talk about if P, then Q. All right, these are the letters and that geometry is used, P and Q, kind of like how algebra has claimed X and Y. So geometry takes P, then Q. So, looking at if an animal is a dolphin, then it is a mammal. What is the P portion of the statement here? If, say it?
Dolphin.
A dolphin.
If a dolphin.
No.
If an animal is a dolphin.
There you go. If an animal is a dolphin, so you can put it like this. We're breaking down the logic. Then, what is the Q portion of the statement?
It is a mammal.
It is a mammal, meaning it meaning the animal. Fair enough? Okay. Now, so, we're going to talk about negating something. Negate, negation. N-E-G, all right? What do you think that means? To negate. If I were to negate what you're saying. What
To
am I?
disagree.
Disagree, it's actually like say the not version of it. To flip it entirely the
agree.
opposite. No, to flip it entirely opposite. So the negation is like this. This means not, okay? Not P means an animal is not a dolphin. Okay? Not P, an animal, an animal is not a dolphin. Okay? What would not Q be? Anyone?
It
This
is
side,
not,
please.
It
Yeah.
is not a mammal.
It is not a mammal, right? Okay. Yes.
But see, that doesn't make sense because sometimes if the animal isn't a dolphin, it could be a mammal.
We're getting there. We're getting there. Okay, good. So now we know what negation is. We know what if-then statements are. Okay? Now, we're going to talk about the term inverse. Inverse is not P, then not Q. Not P, then not Q. Who can say in this statement, this one right here, what the inverse is? If. If what? Yes?
If an animal is not a dolphin, then it is not a mammal.
Okay. If an animal is not a dolphin, then it is not a mammal. Is the inverse true or false?
False.
False. Counterexample. Yeah?
Humans are not dolphins and they are mammals.
Good. Yes. There you go. Okay? The inverse is, if an animal is not a dolphin, then it's not a mammal. We say it's false, because a human is not a dolphin, but it is a mammal. So the inverse is false. Okay? So the inverse is not necessarily true, is what we say. The inverse is not necessarily true. And our friend in the back, hi. When do you think the inverse would be true? You said it before, about when you change things around, flip them up. That's a formula or definition, okay? So what I want you to take is that an inverse is not necessarily true. Now, converse. The shoe. Chuck Taylor, right? Are they nice?
They're amazing.
Chuck Taylor? Never mind, I don't endorse Chuck Taylor at all. I think they're great, not for me, or unless they want to sponsor YayMath. Thanks. All right, Converse is Q, then P. Okay, Q, then P. The definition of Converse is you take your original statement and you flip the order. All right, who can give us the converse? Yes, sir, please. If.
If it's a mammal, then it's a dolphin. Then the animal's a dolphin.
Okay, good, good. You said if it's a mammal, then an animal's a dolphin. You're right. Can you make it in like appropriate English statement? You know, would you start if it is a mammal? So you might have to change the animal around. If.
Okay, if the animal is a mammal.
If an animal's a mammal, then.
Then the animal's a dolphin.
Right. Questions? Repeat. It's okay. If an animal's a mammal, then it's a dolphin. Now, back to you. Is the converse true or false?
It's false.
It's false.
It's not always true.
It's not always true. So, I love, start to adopt the following phrase because it's powerful. Converse is not necessarily true, meaning it's false. So give us a counterexample, please. Remember, to remind everyone, the converse is if an animal's a mammal, then it must be a dolphin. What's your counterexample?
Human.
It's your counterexample.
You can use humans to
Do something more creative.
what?
Platypus?
Yeah.
Do they have offspring and do breast milk and don't lay eggs and stuff like that? Care about their young?
This is the only mammal that lays an egg.
Oh, the platypus is the only mammal that lays an egg. Thank you. All right. Yay, National Geographic. Okay. Last one is called the Contra Positive, and we're perfect for time. It's called Contra Positive. There we go. Contrapositive is not Q, then not P. Not Q, then not P. It's the last one. You're doing great. You're doing great. I hope you find this interesting. I find it interesting. I think it's cool. The platypus part too, yeah. Okay.
Does the little squiggly mean no?
Yes, it means not. It means to negate. Negate. To flip it and make it a not version. Yeah, it does.
And like history.
Yeah, it means about. It also means approximately in other forms. Who can give us the contrapositive? Not Q, then not P. Yes, please go for it.
If an animal is not a mammal, then it is not a dolphin.
If an animal is not a mammal, then it is not a dolphin.
That's
True or false?
True.
Yeah, true.
If an animal is not a mammal, then it is not a
Well,
dolphin.
that's true.
True.
It's true.
So,
always
the last major lesson is the contrapositive is the only one that's true all the time. If the statement's true, the contrapositive is true. So this is true. If the statement's true, the inverse is not necessarily true all the time, sometimes. If the statement is true, the converse is not necessarily true, sometimes. If the statement is true, the contrapositive is true all the time. Yes, question?
So when you're answering one of these questions,
Yeah.
you have to say the inverse is not necessarily true, and then the converse is
No,
not
I would ask you
necessarily
what the
true.
inverse is, and then ask you whether it's true or false.
And then oh,
And then if you say false, you have to provide a
convert.
No,
True.
counterexample.
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 Okay, and then also just
Also, yeah,
quick.
quick.
The
Quick.
statement can be true though.
Yeah, this statement's true.
Okay, so the statement can be true when you flip it around and twist it and pick it apart. There's false and truths to that.
Exactly, that's the point of this
Spin
lesson.
it is like different.
Sometimes true, sometimes false, and it's your job to prove it true or false. And easier to prove something false.
Then
As
prove something.
one example. Last question, yep.
Okay, so like if you start out with your original statement, can it say not in it? So like, could you
Sure,
say
sure.
if an animal is not, like you could start with,
Yeah.
okay.
And then the not of that would be if it is. Okay, everyone, thank you very much. Bye, bye. Wait.
YayMath.
YayMath.
Okay, quick.
YayMath.
YayMath.
Did it?